So we ran out of time there, so into video 2. So is there another number that goes into both 11 and 2? No. Reason being, they're both prime numbers, so nothing goes into them, in fact, apart from one of themselves. So our initial ratio consisted of £13, and it was £11 to this person and £2 to this person. Okay. All that happened was there was now £52 to share out. So that was actually 4 times bigger. 13 times 4 is 52. So we made the numbers 4 times bigger as well. So here's our initial simplified ratio there. So when you simplify ratio, it's on the biggest number, highest common factor, if you like, that goes into both the numbers given, and then divide by that number. Okay, so what's the missing size of the angle in the triangle? So here's our missing angle. So all we need to know is what they're trying to get out of us here. Well, the fact is that in a triangle, all the angles add up to a total of 180 degrees. So really now it's just a calculation of what is 180, take away 42, take away 97, and that will leave us with our missing angle. Okay, so you can do that in any order. You could maybe add up the 42 and 97 first, and then take that away from 180. Let's perhaps do that. So 97 plus 42. So 7 add 2 is 9, and 9 add 4 is 13. So it's 139. So now we're going to do the 180, lose the 139, which takes into account these two angles to see what we're left with. 0 take away 9 can't do. Let's borrow. So that goes down to a 7, and that becomes a 10. So 10 take away 9 is 1, 7 take away 3 is 4, and 1 take away 1 is nothing. So our missing angle there is 41. Okay. Right, work out 912 times 13. We'll be careful this week. I believe I got the multiplication wrong last week. So let's make sure we get this set out nicely. So I'm going to go for this grid method again. So I've got 900s. The addition I did wrong at the end, and then a 10, and then a 2 units. Okay, so 900s, 1, 10, and 2 units. And then coming in down here, I've got in the 13, I've got 110, and I've got 3 units. Okay, and just as a reminder, why can we do that? Well, it's because we could write this as 900 and 10 and 2 times by 10 add 3. So I can break up each of the numbers themselves, and this just creates lots of separate multiplications. And if I add those up at the end, then I'll end up with a total. Okay, this is actually a really important thing to remember when it comes to algebra as well. So let's go on to this end. So 9 times 1 is 9. How many zeros to hold that place? Well, it's in the 10 and the hundreds units here, so that will make it a number of order 1,000. So 1, 2, 3 zeros. And then 10 times 10 is 100. 10 times 2 is 20. Coming down, 3 times 9 is 27, and 2 zeros. 3 times 10 is 30, and 3 times 2 is 6. Carefully add these up. So I've got 9,000. I've got 2,700. I've got a 100. I've got a 30. 20 and a 6. I'm going to add them up. My face is going to get in the way of this, isn't it? I'll draw the line here, but I'll do the numbers over here. So in the units, I've got, there you go, 6 units. In the tens, 5 tens. In the hundreds, 7 add 1 is 8. And then in the thousands, I've got 9 add 2, so that's 11. So 11,856. Okay, so next one. For algebra, actually quite straightforward. So this is called an expression. It's not an equation to solve. We're simply going to substitute in the value of 8, where we see a, and then add the two numbers together. So instead of a add 12, we'll have 8 add 12, and that gets us to 20. Okay, nice easy one there. Work out and simplify 3/5 times 2/3. There's a lot of work that you will do at secondary school to get into this, and I'm not going to fudge it by showing you the hard and fast rule now. I want you to us to think about when we multiply two fractions, what do we do and why? And the best one to start with is, what is 1/2 times by 1/2? Okay, so normally when we do multiplication, whole numbers if you like, 3 times 4, it's 3 lots of 4. Okay, so take 3 and have 4 lots of them, or we can say it the way around, take 4 and have 3 lots of them. And in this case, when I do 1/2 times 1/2, I want a half, lots of a half, if you will. And only a picture really will explain this. And we actually did this earlier when we talked about quarters. So I take a half, and I want a half of that. I want half lots of a half. Well, here's my 1/2. I want a half of that. Not 3 of them or 4 of them, a half of it. Okay. And of course, that gives us 1/4. So here's all my quarters there. So I take a half and halve it, I get a quarter. So what we want to do when we multiply fractions, if we have a look, is if we write down the answer of 1/4, when we halve a fraction, or we say, well, how many of these fractions, if you like, halves, do we want to put into the original fraction? So I want to get 2 things into something that was already broken up into 2 bits, okay? So here's one thing broken up into 2 bits, and now I want to get 2 things into each of those bits. So that breaks those 2 halves up, and I get quarters, okay? So our denominator comes from doing 2 times 2. I have 2 things, and I want to put 2 more things inside them, okay, to make them have twice as many as I did before. So 2 times 2 gives me 4. And the numerator just says, well, how many of those do you want? Okay, so I want 1/2 of 1, and in fact, I've got 1 in my numerator, so I just want to do 1 times 1 and get 1. So I just want 1 of the things that I've made. Okay, so from that, we can see a nice rule appears where the bottom number, I've got to do 2 times 2, that gives me my new denominator, my new how many bits have I broken up into, and my numerator simply tells me how many of those do I want. Okay, let's apply that rule over here then. So I want 3/5 of 2/3, so my fraction is originally broken up into thirds, I should say, sorry. And now I want to jam into those fifths, okay? So if every third now is broken up into 5 more bits, there would be 15 bits in total, okay, around my circle. So I go down to 15, so 5 times 3. And then how many of those do I want? Well, 3 times 2. So I want 6 of those. So it's a really nice, straightforward thing to do multiplying fractions. But it's good to see where, hopefully, it comes from. Okay. Then finally, oh no, sorry, not finally, we have to simplify our answer. So simplifying fractions, we looked up earlier at simplifying fractions here, so and finding equivalent fractions. So 5, 6 worked its way up to 20 out of 24. Equally, I could go back down, so I could divide by 4 here, make the fraction smaller again. At the same size, the numbers are just smaller, I should say, because it's an equivalent fraction. So we're looking for a number that goes into 6 and 15, that's 3. So we can divide by 3, and we get 2 out of 5 as our answer. Okay, so these 2 fractions are exactly the same. We've got 2 out of 5 on a test, and made that test out of 3 times as more marks, so 15 out of 15 now, 3 times bigger than 5. I would expect 3 times as many marks, so 6, and I can do that both ways. I can divide or multiply, okay, to find equivalent fractions, and that's the simplify element of this question. Finally then, 29 fifths is a mixed number. So the first thing I want to do is, if I had in the circles, just keep my eye on the time, I don't want to run out of time, 29 fifths, so here's a hole, and in each hole, 2, 3, 4, 5, I will get 5 fifths, okay? So one hole is 5 fifths, 5 fifths. 10 fifths, then be another circle, that's 2 holes in total. 15 fifths, that'd be 3 whole circles. 20 fifths, that's another 5 fifths, would be 4 circles. And 25 fifths would be 5 circles. And then finally 30 fifths would be 6 whole circles, okay? So that would be adding up 5 each time. So I've got 29 fifths. So in terms of whole circles, I would fill 5 whole circles there. That's 25 out of 5. How many fifths would I then shade in my final circle? I would have, so if I've used up 25, I would have 4 left over because I have 29 in total. So my answer would be 5 whole circles used up and 4 fifths left over. So I'll quickly draw the last circle. So the last circle would actually look like 1, 2, 3, 4 shaded in there. Okay, so it's 5 wholes and 4 fifths to go back to a mixed number. Okay, so well done. Hopefully that was relatively useful to you. As I said, if you've got 10 out of 10, have a go at the advanced, and you're doing a great job for taking part. And I'll see you in week 4.